Okay, we've studied sequences. Now remember a sequence, we looked at a sequence, you know, this is an example of one, 1/2, 1/4, 1/8, 1/16. In other words, these are terms of a sequence, and in particular, the sequence here would be 1/2 to the n. Okay, and you can see that what we focused on with these sequences is the limit. The limit as n goes to infinity of this 1/2 to the n. What is that? Does it converge? In other words, is there a particular number that this equals or not? And in this particular case, this would be 0, okay? Because you can see these terms, you're getting a bigger and bigger denominator, and then the numerator is just staying put. So we would say, okay, that sequence converges to 0. That limit is 0. Now, when we transition over to talk about series, we're no longer talking about those individual terms. What we're talking about is, well, what happens when you start adding these terms? Does this add up to something? In other words, does this converge? And I want to talk about, well, what do we mean by this sum converging? Okay, so here we've got a series, and let me just write it in summation notation. We've got 1/2 to the n as n goes from 1 to infinity. So that's a way we could write that series real succinctly. Okay. And what we want to do is we want to talk about, does that add up to something? Does it converge or does it not? Well, let's just explore this one right here and think about it. And what I want to do is introduce you to this thing called partial sums. Okay, partial sums, a partial sum. Now, I'm going to denote those with, S and then little subscript. So this would be the first partial sum. And the first partial sum is when when basically we just do the first term. So this is 1/2. That's the first partial sum right there. Okay, we're just taking the very first term uh, of that sum. Now, what if I do this? What if I say, okay, well, let's look at the second partial sum. Well, what that's going to be is you're going to go from n equals 1 to 2, and then that's going to look like this. It's going to be 1/2 plus 1/4. And that is the second partial sum. Now, we could do the third partial sum, and that's where we take well, let me just do this. And that's going to be 1/2 plus 1/4 plus 1/8. Okay, that's the third partial sum. Now, one of the things you'll notice as we do these partial sums are terms of a sequence. You could look at it that way. These are terms of a sequence. Okay, I got, and in particular, this one is going to be 1/2. Then this one over here is 1/2 plus 1/4, 1/2 plus 1/4 plus 1/8, and so forth. And you can see we could keep putting in those, but these are terms of a sequence. Okay. So these partial sums, we could think of them as terms of a sequence. So now, let's see here. Let's back up a minute. We've got the first partial sum is 1/2, and let's look at the second partial sum. And what I want to do is add these up. So I've got 1/2 plus 1/4. Well, let's see here. That's going to be, what's that going to be? 3/4? 3/4. Okay. 1/2 plus 1/4 is 3/4. Okay. Now, let's look at the third partial sum. The third partial sum is going to be 3/4 plus, what is the next term? Well, it's going to be 1/8. Now let's see what that's going to be. If we multiply this 2 by 3, we've got, looks like 7/8, right? 7/8. So we've got the first partial sum, the second partial sum, and the third partial sum. And let me put these over here and see what's going on here. Okay, so now we've got a sequence here. And now the question goes back to what we studied previously with sequences. And I'm curious, does this sequence converge? Okay. In other words, what is the limit of the kth partial sum? That's what I want to find out. I want to find out this. I want to find out what is the limit. I'll use k. What is the limit of the kth partial sum? Does it equal something? Does it equal some L out there? Now, if it does, that's what we're going. If this condition is met, then we say that series converges. And what does it converge to? Well, it converges to L. In other words, if we want to talk about whether or not a series converges, the way we answer that question, the way we define that, is we say, what is the limit of the nth partial sum, or the kth partial sum? Okay, so let's see if we can figure that out in this particular case. Now look, okay, so we've got 1 over 2, okay? Here we've got 3 over 4. And here we've got, well, 1 over 2, 3 over 4, 7 over 8. So let's look and see if we can come up with some formula. Let's just see if we can come up with some formula for the kth partial sum. Well, it's going to be a fraction. Now, if you look, let's just look at it part by part, the numerator and denominator. The denominator looks like it's just going to be powers, right? This one right here is 2 to the first, 2 to the second, 2 to the third, right? So S sub k, it looks like that's going to be 2 to the kth power. Yeah, that's pretty obvious, 2 to the kth power. Now, how does the top compare though? Well, we've got 1, 3, and 7. Those are 1 less than the kth power, 2 to the kth power. So maybe that's 2 to the k minus 1. So it looks like the formula for this particular sequence is 2 to the k minus 1 over 2 to the k. Now, so this is the kth partial sum. We want to know, does that series converge? Well, the answer to whether or not that series converges is found in finding this limit. If this limit right here exists, that means that series converges. So let's see if that limit does exist. We take the limit as k goes to infinity of 2 to the k minus 1 over 2 to the k. Now you can see that the dominant force up top is 2 to the k, and the dominant on the bottom is 2 to the k. So this obviously, I mean, we've got this minus 1 up here, but this limit is just going to be 1. So what we found by taking the limit of the kth partial sum, we found that that series converges. That series converges to 1. So here's what we have. We have this series is equal to 1. Yeah. Now, we were able to actually find out the exact value of what it converges to. This particular series, it was easy for us. We could find, yeah, that series converges to 1. Now, that won't always be the case. We won't always be able to find out what a series converges to. So what we're going to focus on for the most part is whether or not the series converges. And as to whether it converges to what it converges to, that's not going to be our concern for the most part. We're going to concern ourselves with, does it converge?